Hello and welcome. Today I will show you some characteristics of the digital elevation model and how we can analyze them in gvSIG. In the next videos I will show you exactly the procedure with some case study. So what is a DEM, digital elevation model? The digital elevation model is a representation of the land providing information of the elevation above the sea level. Naturally, when we download the digital elevation model, it is a grayscale, but as we have seen for other raster, we can convert them and visualize in a color table. So we are more used to see a digital elevation model from green to brown or gray, but when we download it, it is a grayscale image. So how we can visualize? This is a normal visualization, but as we have seen before, we can remove edges and activate, or we can also clip tail in order to have a better visualization of the digital elevation model. You have to notice that even if you clip or remove edges, the value does not change. The only thing that changes is the visualization, but the elevation value of each pixel does not change at all. So you see here, for example, you can see the spatial resolution of the digital elevation model by zooming and then measuring the size of a pixel, and consider that the smaller is the size of the pixel, the more accurate each digital elevation model and the heavier it is in terms of megabyte, and for sure the more precise it is, because usually when you make a digital elevation model with a big size of pixel, it means that all the area contained within one pixel will be assumed the same elevation. So if you have a steep slope, it becomes not so accurate. On the contrary, in quite flat or not so steep area, even 30 or 90 pixel meters can be enough for your purposes. So how you can read them? When you click on a pixel, you will have this info by point with gvSIG, and you have this value, means the elevation value. This is in this case the grayscale. So as I told you before, it's a grayscale image, so all the RGB value will be the same. As well, you have these coordinates, latitude and the view pixel and the pixel point, where you can download the open digital elevation model for all the world. For sure, you have a local digital elevation model with different, let's say, pixel size, different spatial resolution. But if you look at the worldwide digital elevation model, you have mainly these two products, the SRTM and the Aster GDEM, that can be downloaded from these two links. And you have a different tool to look for your digital elevation model and download it. If you register, you can also use your own shapefile to download all the digital elevation model that will cover entirely your study area. So you see that according to your purposes, you can choose one or the other according to the resolution you need. What you can do with a digital elevation model, later on I will show you how you practically can obtain this. You can derive the contour lines. So you see this is the digital elevation model, and from this you can derive contour lines. For sure, remember that you cannot, if you have a pixel size of digital elevation model of 90 meters, you cannot derive extremely accurate contour lines. So basically, do not choose a very short interdistance between contour lines, because it will be not real. You see that when you create your contour lines, you have to select the digital elevation model and the equidistance, and also if you have to derive from maximum and minimum value, and this is the result. You can also derive a slope. So according to your digital elevation model, you have a slope, and the slope is the steepest distance between one cell and one of the 9 surrounding it. And you can express for sure in degrees or percentage. So in gvSIG, you set the elevation model, the method, the unit, as I told before, percentage or degree, and the output. And for sure, you see here the result is a grayscale, so the whitest pixel will be the steepest one. You can derive the aspect from 0 to 360, and you see it means that if you look downwards, this is the aspect of your slope, and in case of absence of slope, you assign by convention a pixel value of -1. As this is the result, as before, you define the DEM, the degrees, the method, and the output. It will be a raster file. And also here you have grayscale image. You have the elevation relief ratio that identifies a quantity measure of the heterogeneity of the area, and for example, it can be very useful to have easy to read information of the morphology of the area. So you see here you have the DEM, and here you have the elevation relief ratio. As I told before, it's very easy in this case. Just set them and define when you want to have your output. Shaded relief is very useful for analyzing wetlands, vegetation, agriculture, and so on. And to define the shaded relief, you have to set up the elevation in the vertical and the line horizontal horizon of the sun. And by this link, you can see what are two parameters giving the time of the day and your position. Here is the interface. Define your aster, the method, the sun elevation, azimuth, and the elevation, the exaggeration, so if you want to enhance the aspect of your result, and the output. So you see this is the result of the shade relief at a given day at a given time in a given position. Protection index is another parameter you can derive from a digital elevation model and analyze the pixel in relation to the closest ones within a given distance, providing the information on how the area is protected from the surrounding hills. In this case, you have to define the DEM and the radius in which you estimate that the protection can be active from the surrounding hills. And this is the result. So the highest value means the highest protection. The real area is very important according to my opinion, because when you have a digital elevation model, a pixel size is not the size of the area, because if it's very steep, 30 by 30 will not be 900, but will be much more on real area due to the steepness. So in this case, you can calculate the real area of a pixel giving the slope, and as well you can derive profile. So let's say that if you have a shapefile, a road, a river, or any linear features, you can derive automatically the profile of the slope, of the line. You see this is the line, and in this case you can use this result. You can have this result, and you can export this result as an image to import in any report or any data you want to publish. The last one is the selection of the area with a given elevation. So maybe it can be interesting to know all the pixels of a given area that are below, above, or within an elevation range. So you select, let's say, the digital elevation model, and say, show me, for example, all the area that are higher than 1000 meters. So here you just say by raster calculator. I will show you how to do, and this is the result. You see, it's very easy, just as other raster, define the output and the pixel size, and this is the result. So you can see, or you can use later on as a mask, the pixels that are above, under, or within a given interval. Thank you so much.